All right, welcome back, class. This will be 7.3b, hyperbolas centered at hk. So rather than centered at the origin, now it will be some hk on our graph. When we're looking down here, the standard formula of our equation, there's a lot going on, but we're just focused on this bottom one. This will be hyperbolas centered at hk. And something to note is that, again, our a squared will always come first regardless of x or y. And you always associate your h with your x and your k with your y. So that'll be something to keep track of, because when we find the center, it's of hk. But like in this case, since y comes first, our k is first here, and then it flips. So be aware of that, and I'll try to thoroughly go over that through the videos. Again here, if y leads, then we have a vertical focal axis, but now it's centered at hk. So from the center, we're going to go our k value plus or minus c, and then when x leads, it's a horizontal focal axis. So h will shift plus or minus c to the left or to the right. Yet again, to find our foci, oops, I want to use a pen there. Foci, we use the equation here. So it's plus again, since it's minus and minus, so the opposite of what it was for ellipses. All right, starting with the first example, it leads with y. So that means our k value is associated with y and our h value is associated with x. So our center is going to be 3, 9. So I'm going to scale this. I think that'll help fit everything on the graph. So 2, 3, 2, 4, 6, 8, 9. That is our center. Since y leads, it's going to open up and down. Our a value, or a squared, is always first, followed by b squared. Our vertices will shift vertically, so that means our h value is going to remain the same. And then to find our a, we take the square root. So we do 9 plus or minus 7, because our center is at 3, 9. So from 9 units up, you go plus 7 or minus 7. So that's going to be 3, 2, and 3, 16. So 3, 2, and this was 9, so 10, 12, 14, 16. Then to find where it shifts, or to find the b, that'd be 2 equals b, so that'll move horizontally plus or minus 2 from that point. Now we can draw our box. And then our foci is a squared plus b squared equals c squared, and we have those values up there. So 49 plus 4 equals c squared, 53 equals c squared, c equals radical 53. Our focal points are on the vertical axis, so our h, again, our h value will remain the same. So we have 3, and then 9 plus or minus radical 53. And I got this to approximate to, let's check my notes, 7.3. So 9 minus 7.3 will be just outside here, and then 9 plus 7.3 will be just outside here. To find our slope is, again, rise over run. So from the center to this point is 7 units, and then over 2. So 7, 2, and then down is going to be 7 units, and then over 2. Oh, and this should be right here, not the focal point up there. So negative 7, 2. Now, we do have values for y1, x1. That's from our center values here. So to write the equation, it's y minus 9, because this is xy, equals our slope plus or minus 7/2 x minus 3. So those will be our asymptotes, which go through the diagonals, there, and then there. And we said it opens up and down, so we approximate and get as close as we can get without touching the asymptotes. All right, next, now it leads with x squared, or excuse me, our x value, so x plus 2 squared over 16 minus y plus 3 squared over 9 equals 1. It leads with x, so it opens left and right. Reiterating that our h and k correspond to x and y respectively. So we do the opposite of plus, or the inside. So if it's a plus 2, it's a minus 2, minus 3. So our center, minus 2, minus 3. I left it there in green. Since our hyperbola opens left and right, our vertices are going to shift left and right. So this is our a squared. So our a value is 4. We'll solve for b squared in a second. So our k value will remain the same this time. So negative 3. But we're going to move plus or minus 4 from negative 2. So negative 2 minus 4 is negative 6. Negative 2 plus 4 is 2, negative 3. Let me just check my notes real quick to ensure that that's what I got. Yep, that looks good. So negative 6, 2, 4, 6, 3, and then 2, negative 3. Now we can use our b value here, which b squared is 9. So taking the square root, b is 3. So right here and right here, we can create our box. That looks nicer than my circles and ellipses, I think. Our foci is a squared plus b squared equals c squared. So 25 equals c squared, so c equals 5. It's horizontal, so from the center we have a negative 2 minus 5, so negative 7, negative 3, and then we have a negative 2 plus 5, so that'll be 3, negative 3. Let's check, that looks good. And to reiterate, the center, the focal points are horizontal, and now they should be outside of our vertices here. So negative 7 will be here, and then 3 will be here. So that's what we were looking for. Our slope is going to be 1, 2, 3, 1, 2, 3, 4. And it's going to be plus or minus, because we also can go down and then over 4. We're using our center values for y1, x1 again. So y minus a negative 3 equals plus or minus 3/4 x minus a negative 2. So these values of y1, x1 came from our values of x, y here. So then, simplifying, we have y plus 3 equals plus or minus 3/4 x plus 2. These are our asymptotes. They go through the diagonals. And it opens left and right. We have our focal points. We approach the asymptotes. Okay, so this is where I could see some getting confused. Now it leads with x again, so opens left and right. But let's not forget that with hyperbolas, unlike ellipses, we're not looking for the greater value. It always leads with a squared. So although 256 is bigger, that'll be our b squared, because ellipses lead with a squared. Our center is our hk, So 4, 2. We're going to plot that, and I'm going to go 2s again. So 2, 4, 2. Then it opens left and right, so our vertices are going to be plus or minus a from the center here. So a, when we take the square root, is going to be 12. So 4 minus 12 is negative 8, 2. And 4 plus 12 is 16, 2. So negative 8 is 2, negative 2, 4, 6, 8, 2. And then that's 4. So 4, 6, 8, 10, 12, 2. Is 1 shifted too far? 1, 2, 3. I think 1 is. Oh, that's supposed to be 16. So 4, 6, 8, 10, 12, 14, 16. There, that looks a little more centered. To find RB, we take the square root of 256, which when you solve that, you'll get 16. So now from the center, it's going to be plus or minus 16. So 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. Oh, wow. That's hard to keep track of with how big the graph is. The foci, a squared plus b squared equals c squared. When you add those together, you get 400 equals c squared, and then c will be 20. So the focal points are on the x-axis because it opens left and right. So we're going to shift plus or minus 20 from negative 8. So negative 8 minus 20 is, or excuse me, from the center. So 4 minus 20 is negative 16, 2, and then plus 4, or 2, 4 plus 20 is 24, 2. So we have negative 16, so this is 8, 10, 12, 14, 16, and then 24, 16. That still exists off the graph out here. We can draw our box all the way around. Our slope, rise over run. So from the center, it's going to be up 16 and over 12. And that's plus or minus. So we can reduce that down to a plus or minus 4/3. Using our center values for y1, x1, we have y minus 2, equals our slopes, and then x minus 4. Those are our asymptotes. And it opens left and right. I lost my left focal point. I think it's about there. Or my left vertice. All right, now we have some information to help us write the standard form of the equation. And I lost that one. So starting, it says it has foci of negative 1, 2, and 5, 2, so we can graph those. Negative 1, 2, and then 5, 2. So 1, 2, 3, 4, 5, 2. And vertices of 0, 2, 4, 2. So 0, 2, and then 4, 2. So to find our a value, a is associated with vertices. We can find this total distance, 1, 2, 3, 4. So that's our diameter, so 2a equals 4. We can then do the same for our c, which is associated with our foci. So from there to there is going to be, let's count, 1, 2, 3, 4, 5, plus 1 is 6, so 2c equals 6. Since our x values are shifting, it's going to open left and right. So the standard form of the equation is going to be x minus h squared over a squared, minus y minus k squared over b squared equals 1. 2a equals 4, so a equals 2. So we can solve a squared will be 4 again. 2c equals 6 here, and I'm pulling these from the distance we found on the graph. So solving for c, we get c equals 3, and then c squared equals 9. The reason why I'm finding these is because now we can use this in our formula to find c squared. A squared plus b squared equals c squared, to plug it in to find b squared. So we have 4 plus b squared equals 9. So solving for b squared, we get 5. B squared equals 5. Also, the center, since it shifts horizontally, will exist on this axis here. So if we can find the midpoint, we can find the center. So if 2a equals 4, we got a equals 2. So from this point, if we go plus 2, right here, that'll be our center. So the center is going to be 2, 2. Now we have enough information to write our equation. So we have x minus 2 squared over a squared, which was 4, minus y minus 2 squared over b squared, which was 5, all equals to 1. So that'll be our equation from the information they gave us. And I think that'll be enough for now. If you have any more questions, be sure to email me, and thanks for watching.